Hey guys, welcome back to the Real Hacker Hours podcast. This is basically where I just do the normal work I would on side projects. I just hit the record button before I do it. Today we're going to be continuing on with Apache Vuln research, and what I'm going to be writing right now is a fuzzer for Apache modules. Now, what that will entail, the purpose of this is so that it can develop a ton of different fuzzers for a ton of different modules. Now, the thing is with Apache modules, the functionality that a lot of them have is relatively small, and there is a bit of overlap between different modules. So hopefully what I'll be able to do is develop effectively a fuzzing framework, in which case I can let's say I want to fuzz modder. A lot of the functionality that I would already need to fuzz a module is already there, and I just have to add like a little bit of module specific logic to it, and then it can just go. That being said, let's get started. I have to make the project. Right now I'm listening to this song by Trivium, so that's what it's going to be named. Cool. Now, x.py. This is it. I'm gonna write our. So how we're gonna do this? So what I plan on doing is here. Let me. Gonna make a directory called modules. So what I plan on doing is having a module class that will have all like the base functionality that we should expect most modules to have. And then when writing a new module, I can just inherit that module, and I should have most of the functionality there already. I just might have to like override a few things. So let's get done with that. Also, just saying, this particular podcast will be heavily dev oriented since I'm making a new tool. Cool, so let's go ahead and module.py. So we're going to have a class module. And let's see, wait, no. Init. And we just have in here, let's just have something like self. Just something there. Let's just run it real quick just to make sure we don't have a syntax error. Okay, cool. Now, for a module, what functionality will we need? We'll need the ability to generate a packet, which I'm just right now adding the functions that I'll need, the functionality that they actually will give, or the functionality that they'll have, I'm going to write after I establish everything. And let's write this properly. Bytes, add that type hint. And for a generated packet. Now, for HTTP packets, if I recall correctly, they have two components to them, a header and a body. So let's just go ahead and add that. Generate header self bytes, return that, and generate body, and then gonna return that. Cool. In the packet, realistically, all it should be is we get the header, we get the body, the packet is just equal to header plus body, and we return the packet. Cool. That being said, let me just do a little bit Googling just to confirm this. Structure of HTTP packet. Just a request line, 0 or more header fields followed by. Okay, I might have been wrong. HTTP request. The request line header and a body. So it's request line header and body. So let's add the def generate request. So the first two modules I'm going to write a fuzzer for will be moddir and mod alias. The reason behind them is that they are extremely simple modules that it's very easy to write modules for or module specific fuzzers for those. So that's why I'm starting with those two. I'll branch off later to more of them. So for generate requests, what is the request? A request contains a method and an object, like with the file path that's actually, or the resource it's trying to access. The other is get, post, put, head, delete, patch options. So let's make a function to get the method. Self return. For now, I'm just going to do get. And the reason why I want this function to be specific to the module, not in some like utils file, is because I want the module to have control over, like, oh hey, is this, or can it specify, oh hey, I only want post requests, I want get post put, I want all requests other than delete. That way, in case that there's a module where that functionality actually becomes important, I can include it. So for now, we're going to do that. Method equals self.get method. Cool. Just going to look up HTTP request line. Request line begins with a method token followed by a request URI in the protocol version. Method space request URI space HTTP. Okay, cool. So the request line contains 3 different components according to this portion of the RFC. RFC is just a document that explains how the HTTP protocol works. Method space the URI for the request space the HTTP version. So we're going to need URI equals self.get URI, and then HTTP version equals self.get HTTP version. Request line is equal to %b, %b, %b being the method, the URI, and the HTTP version. Now, one thing that's missing from here is this right here, Control LF. To see what that is, I can just fire up Wireshark or look at docs, but I think that Wireshark might be a bit quicker, so I'm going to go this route. Loop back. Follow TCP stream. Okay, cool. We're going to need to get Apache working. No, yeah, before we can run that. No biggie. Sudo here we go. We see here is the request line method. the URI and the HTTP version. And let's look here. 31.31.0D0A. So this right here is effectively a kind of just like it's a terminator for the at least the request line. I think we might see it at multiple points in here. Let's see. User agent Linux GNU. Yeah, we see it again here at the end of this line. So effectively what this terminator looks like is effectively just like a new line terminator. So this will probably, actually, here we go. This we could specify in like a utils or like an enums file. Just gonna save enums.py crlf equals 0d 0a import enums. Wait, is that? I feel like the standard Python enums. Okay, it's not. Cool. We can go with that. And then we can add then enums dot crl. Cool. So now we need the get URI and get version. Or these might be, they should probably be generate or I'm not worried about that right now. Primary difference between generate, or at least with my like coding, generate and get, is generation or get is like we're choosing from a predefined selected list. Generate is we're actually generating new data. URI, there's only a set amount of URI like files or resources that we can access, so I'm gonna leave it as get for now. Get URI self, gonna return 127.0.0.1. Let's take a look at this right here. Get slash. Yeah, actually, let's just get the root resource for now, and def get HTTP version. For now, I'm just going to return HTTP 1.1. I believe, yeah, there are a few different versions of HTTP we could use. However, I believe 1.1 is the most common. What version of HTTP is common? 1.1. Okay, according to Google, it's 1.1. But yeah, you see there's like 0.9, 1.0, 1.1. So we'd probably want to like implement like a random choice between those for the fuzzer. So cool. What do we have here? We have the request line, header generation, and body generation. Now for both the mod alias and mod dir, all of the functionality we have to deal with primarily deals with the request line. So for now, I am perfectly cool with leaving the generate header and the generate body as effectively just empty. That being said, dump. One thing I am curious of is I remember reading that certain delimiters are needed, but for now, I'm gonna just try it as is and see how it works. Cool. So you have a basic module here. Let's go ahead and start actually writing the fuzzer component of it that will import the module and then generate the data. So class module fuzzer definite. We're going to need to definitely import modules module.py. Not sure if that's the right syntax. Probably going to have to Google. It's been a bit since I've written Python code. So let's do what do we have in it? We're going to need self.populate modules. Self.modules def populate modules. So one thing I am imagining this fuzzer is going to probably be able to do is, in my head, this is the model I have for it running. We're going to have an Apache, let's say we're wanting to fuzz 5 different modules. We will have an Apache module up with those 5 modules loaded. Now, there might be various virtual hosts available with different configurations of those modules. However, this fuzzer will have a config or have a module code segment enabled for all 5 of those modules, and I'll be fuzzing all 5 of them at the same time or concurrently. Or rather, like this packet, we're going to fuzz the first module. This packet, we're going to fuzz the 4th module. This packet, we're going to fuzz the 3rd module. So yeah, populate modules. This is going to where we're going to actually have to establish, oh hey, these are all the different modules. So new module equal. Actually, let's first make sure that this runs correctly. Print hello. I forget what's the syntax for like the Python 3. It's like if name is equal to main. Yeah, here we go. If name is equal to main. Just make sure that this is working. Okay, so module.py is working. Import modules. I might need import enums. Okay, I think I might need to change this. Import modules. No module named module. Oh, need to get rid of the .py. Okay, this is working. So what I had to do was since this is being imported from the base directory of the project that's where we're running it, and modules is in a subdirectory, I had just to effectively specify it relative to where the import relative to where I was running it from. Cool. So this is working. Now let's do module fuzzer equals module fuzzer. Let's make sure this is running correctly. Takes 0. Oh, this init takes self as an argument. Cool. So that's working since there's 2 hello statements. Cool. Now what will we do? So how do I imagine? Well, first let's define a list as to these are the module types that we are going to use. Let's do it from here. First, let's make sure that what I'm imagining doing is having a list of like modules to fuzz equals, and then we specify like, oh hey, module mod alias, stuff like that. Let's first make sure that we can see it from here. Module. Okay, so we can indeed see that class from here. I'm gonna change this to from import all. Actually, let's do import module. This way, we shouldn't need that there. Okay, cool. We no longer need that there. That's great. Let's do self.poppy like modules def populate modules. Cool. Print module. Let's make sure that this still works. Oh, I forgot the self. So this is working. Cool. Cool. What comes next? Okay, next we're actually need to new module equals module self dot modules dot append new module. Let's print self dot modules. Cool. Okay, cool. So it is indeed able to establish the module and append it to itself. Next, let's see if from here it can see module. Okay, cool. So let's turn this into a list. That way I can do this. I can iterate through the module in modules. So here what I'm able to do is I'm able to, actually, let me just add one more print statement here. Print. Okay, so yeah, able to establish a list here. These are the various modules I'm going to fuzz. This function right here effectively just iterate through this loop, adding each module to there. And yeah, let's have a def fuzz while true. Packet module equals self dot get module. Packet equals module dot generate packet, and then we print that packet. Now we're going to need a get module function. The purpose of this function will be is to randomly select which module we'll be looking at for this fuzzing iteration. Cool. Okay, so we have this here. We can just do a module equals random dot choice self dot modules. To return that module, we will need to import random. Cool. So let's add this line right here to actually start fuzzing it. So if this works, I should just start printing out a bunch of packets. Forgot the self again. Ooh, wow. Oh, that should not be callable. Cool. So as you can see here, it's continually running and printing out, but it's not actually. No, print. Well, the package is generating. It has empty. Reason for that being is I made a smooth brain mistake over here. I have functionality for generating request, header, and body, but for the packet, I only include the header and the body. So let's add the request line equals self.generate request. And just for the sake of concurrent naming conventions, let's add, well, append this to here. Get HTTP version. Forgot self again. So let's add on the type hints. Enums. Oh. From import CRLF. And then we should be able to get rid of that. Cool. And for the request line, we're just returning empty. We're not actually returning the request line. And here, okay, cool. So now we can see that we are continually generating the same request line. Cool. I'm gonna pause the video for 1 second. Okay, I'm back. Cool. So next up, we probably should start implementing a bit more entropy into the request line, since for at least the modules we've looked at so far, that's where a lot of the functionality is. So first off, what we can do is we need to import random for this. In enums, we can specify for us a method. What is the right term here? Methods list, and then we can just have list of methods here. There's get, post, options, get, head, post. Okay, I'm just gonna add all of these. Options, get, head, post, put. Delete. Trace and connect. Cool. So we have that there. Methods list. You could change this to random.choice methods list. And now the verb should alternate between several different things. And we're seeing it's alternating. Cool. Next thing on the list to add entropy to is the URI. Now, in order to have this done from a perspective of having a correct data, which it should be able to. We all need to have knowledge as to what resources or files or directories are actually on the web app, which varies between all the htdocs directories. It varies between every single one. So we will have to have like a config file or something like that that just says, hey, these are the valid resources available. For now, what I could probably do is just have like a list in enums as to like, hey, these are all the valid files and directories. So let's do that here. Well, no. What will probably be better, what I'm imagining is you could just like make a directory and file objects itself and just keep track of like the root directory and which directories are parents of which, and we could have some functionality like that. Hang on a second. Okay, so looking at it, there's a lot of functionality that I'm going to have to write before I get to the point where I can start writing actual module specific fuzzers. So, and since this has been basically 30 minutes of just Python dev, simple Python dev, nothing like specific to a module, I'm just going to end it off here. See you later.